All right, let's talk about and weigh the options of nuclear sources of energy. The economic advantages are real. The energy in 1 pound of highly enriched uranium is comparable to that of 1 million gallons of gasoline. Tremendous amounts of energy potential here. The energy in 1 pound of uranium is 1 million times as much energy as in 1 pound of coal. All right, it prevents carbon dioxide emissions. We have a storied history with nuclear energy since the 1950s, and the world produces about 17% of its electricity from nuclear power. All right, so if we look at the United States here, you see that most of the nuclear power plants are focused in the East Coast, all right, where most of the population lives. All right, very few out in the western part of our country. Okay, and if you notice, Illinois stands out as a particularly rich region in nuclear energy. However, look at Pennsylvania. We have 9 licensed nuclear power plants operating within our state alone. All right, and if you look around the world, you can see some of the countries that have gone nuclear. South Africa has a plant. All right, Brazil. And then you can see the ones dotted in and around Japan and India. All right, but most are in North America and Europe and Russia. Okay, so we are a nuclear world. All right, and a lot of countries have said yes to this particular form of energy. So we have to weigh the risks and benefits when it comes to nuclear energy. You should know that France leads the world in the percent of electricity that it produces from nuclear energy. It's a little over 75% of its entire energy needs that France generates via nuclear energy. All right, but when it comes to the amount of electricity produced by nuclear, the United States leads the world. All right, it almost doubles the amount that France generates from this source. So even though France makes most of its energy that it needs from nuclear energy, it's the United States that leads the world in energy production from nuclear power. All right, at the front end, you should know that uranium mining has a significant impact on the environment. All right, it's in the form of surface mines, open pit mines, and strip mines that we mine for uranium. And it's blurry, but on the right hand side you can see where it's found. All right, we're talking about Canada, the United States, Australia, China, Africa. So uranium is found all over the world, but just kind of realize that the mining for uranium has all the impacts that we've already talked about when it comes to mining. All right, which includes tailings piles. All right, now in other forms of mining, tailings piles leads to acid mine runoff. That still occurs here with uranium tailings piles. However, these have a very unique environmental impact in that uranium tailings are radioactive. All right, and uranium will break down naturally into radium and then radon. All right, so tailings piles from uranium mines actually include radon, which is a hazardous substance. When inhaled, it can lead to things like lung cancer. So uranium's tailings piles are unique and dangerous for a different reason other than acid mine runoff. They include radon. Okay, and you can notice here at the bottom right, the map there of the United States. A lot of mines are in the west, but there you got one there dotted in the southwestern part of our state. Okay, so once you mine the uranium, we have to get it into a form where we can use it as a fuel source. So what we do is we make the uranium and formulate them into fuel pellets. All right, and then the fuel assembly is put together as a series of rods, and then that becomes the fuel. All right, these rods of fuel pellets. Okay, and you get a sense here. Those fuel rods will later become spent nuclear waste. All right, we're going to have to store them as nuclear waste, but you can get a sense for the fuel pellets. All right, and here's what a reactor core might look like. So those rods are then inserted into the core reactor where it's going to boil water, turn to steam, and generate electricity. A little bit about the fission reaction before we go here. Just know that it is a fission reaction, so the atom is split. We start with uranium-235, which naturally breaks down into barium and kryptonite. All right. So from that spontaneous breakdown, all right, you get a little bit of energy released, and that energy is what we're going to use to boil water to turn to steam to turn a turbine. All right. So now what happens is, and how the reaction continues, and release a neutron, which then bombards another uranium-235 atom, which will then break down into barium and kryptonite and release a little energy. So you have a nuclear chain reaction in that a neutron released from the first reaction will bombard a fissionable material like uranium-235 and just continue to split the uranium atoms. So as long as you have uranium-235 atoms within the fuel pellets, all right, you can have a nuclear chain reaction. Okay, so what we're doing is we're using this chain reaction to harness the energy to boil water, to turn to steam, to turn a turbine, and generate electricity. Okay, in a nuclear core reactor, you have a couple things. All right, the first thing here is a containment building. Now, this can be a 17-foot thick wall of concrete that contains the core reactor, and the core reactor is literally just a container that contains water and the fuel pellets and control rods. Now, the control rods are there to control the rate of reaction. All right, you don't want these things to get too hot. You don't want the reaction to happen too fast, or you'll have what's called a meltdown. All right, so as long as there's a reaction, there's heat being generated within the core reactor. So what we're going to do is we're going to pass water, all right, through a pipe within the core reactor, and that water will turn to steam. Okay, and then that steam, which is highly pressurized, get pumped into a turbine, which will spin these blades. All right, and as long as it's hooked up to a generator, it can convert that energy into electricity and out onto the power grid. Okay, that water then continues on its way and is cooled down and can be used again. So a pretty simple process. We're using the reaction to generate heat to boil water, turn it to steam, so it can turn a turbine, which is hooked up to a generator, which generates electricity. Okay, hopefully that makes sense to you. All right, so there you go. There's the process in motion. The problems with nuclear energy is that there's no permanent disposal method for nuclear waste, all right, and we've actually had some accidents in the world. We talked about Yucca Mountain as being available, however, politically it just hasn't really gotten the go-ahead to accept nuclear waste around the country, so our nuclear waste still lies inside the nuclear power plants where it was generated. So right now we have no permanent disposal method. And the accidents you should really know about are 3 Mile Island in 1979, Chernobyl, which was in 86, and then Fukushima just a short 3 years ago. Alright, so let's take a look at some of these incidents. Alright, 3 Mile Island in 1979. This is out in the middle of the state of Pennsylvania, right near Harrisburg. Alright, this plant experienced a meltdown. All right, it was actually pretty bad. However, the container that holds the core, that 17-foot thick wall of concrete, actually kept the meltdown contained. All right, it did not melt through that container. There was no explosion. However, inside, the fuel pellets did begin to melt, and it released a great amount of radiation in the immediate area. So they called it a partial meltdown. If you notice here, it was highly publicized. All right, it was a nuclear disaster. Okay, nearby a populated area of Harrisburg. So it was in 1979 a huge event because it was right around the time when environmentalism was just recently kick-started and people started to doubt nuclear as a potential source for energy. All right, a second disaster happened in Chernobyl in 1986, and this time there was actually an explosion during a training drill at the core reactor. So the explosion blew up the core reactor and contaminated the atmosphere, the ground, the local environment for miles. All right, so this was actually an explosion and turned into a disaster. And if you notice here, the wind currents at the time took radiation hundreds and hundreds of miles all over northern Russia and even into Western Europe. All right, here's the building today. Their solution was to build a structure around the exploded core reactor, and that structure is still there today. It's at this point crumbling and becoming a problem, as they're going to have to try and figure out another solution as this building is starting to fail. All right, so they didn't really have a solution at the time. It was just basically to contain the core reactor and the remnants of the building. All right, a lot of iconic pictures come out of this area. There's a lot of stories around this event. All right, the townspeople were not really notified. It was kept hidden for a few days, and people received an unhealthy dose of radiation. The people of Chernobyl, which was a town of a couple of thousand people. So you'll see pictures like this, just the left behind remnants of a city where people were quickly evacuated after they were given notice that this disaster had happened. All right, and even today, things remain radioactive. Okay, it's the trees, the grasses, the weeds, the animals, the mushrooms, everything contains radioactive material. So if you ate this mushroom, you would receive radiation. Okay, at this point in time, they've closed the area. They call it the exclusion zone. All right, you can go there to tour at your own risk. You will receive a bit of radiation from going in this area. It is not a lethal dose. Okay, you can go to visit this area and tour and take pictures, and you will receive radiation. All right, but it's not a lethal dose by any means. However, the area does continue to be radioactive. Okay, just some pictures of some scientists doing some testing on some of the animals in and around the area. All right, continuing to measure high levels of radiation in the environment and in the organisms that inhabit it. All right, and now this is one that is so interesting because this happened in 2013, and it was an event that was warned against, okay, because where Japan is located in the world, it's nearby a dangerous fault line, and sure enough, there was an earthquake under the water in the Pacific Ocean that generated a tsunami, which landed on shore of Japan and literally smashed into the Fukushima Daiichi nuclear power plant in Japan. All right, now, what was so dangerous about this one is that many of the buildings exploded or caught fire, and some of the ones that exploded were the ones that were actively generating nuclear energy and also storing some of their spent nuclear fuel, all right, their nuclear waste. That waste and the radioactive materials, which were on the shore, on the shoreline, on the coast, then entered the ocean. They entered the groundwater supply. All right, here's a picture of where the earthquake happened, all right, which sent out a wave which smashed into the Fukushima Daiichi nuclear power plant. All right, but that tsunami left nothing intact. Okay, you can see a boat here just washed into town. All right, it was a huge, huge disaster. Here's actually two of the buildings that were storing nuclear waste. Okay, just totally wrecked. Okay, and some of that waste was measured in the seawater, and the ocean currents were taking it directly east, okay, towards the United States. So that waste then started to wash up on our beaches and shores, and which really exacerbated the nuclear fallout area. All right, so people immediately after the disaster were being tested for radiation, all right, and lots of them were discovered to have received unhealthy high doses of radiation. All right, so after these events, it's easy to kind of think negatively on nuclear energy. However, you could think about it in a different way, in that we should be learning from these experiences. All right, so you need to weigh the options. Uranium is abundant. Okay, this type of energy helps the discussion on global warming because there's no carbon dioxide emissions. Hopefully, new technologies and learning from our mistakes can help make nuclear safer. All right, it's a good choice for developing nations, especially as the discussion of global warming continues. All right, it creates high-level engineering jobs. All right, we can reprocess the waste, which reduces the half-life. And after the high initial cost of building a nuclear power plant, it's cheap and it produces lots and lots of energy. Okay, but we cannot forget that when you're dealing with nuclear energy, all right, there's always the potential for accidents. Okay, there is high initial cost. Okay, and the problem with nuclear waste is not going away. We still do not have any permanent facility. Okay, and then I didn't mention, but this is something to be concerned about. All right, maybe this will change someday, but right now we have no way to turn off fission reaction once it starts. If something happened, we have no way to turn off the reaction. All right, there's no off button. It's a slow process to stop the reaction. Okay. The other thing we need to be concerned about is these developing nations who are telling us they're going nuclear to make energy. We have to be concerned that they're enriching uranium to make weapons. Okay, so that's a concern. However, if places like Iran would use nuclear energy for power, for electricity generation, it would absolutely propel their country into a good economic standing. All right, this would definitely help a situation like Iran to unite that country through electricity. All right, there is an impact on wildlife, and we need to be concerned about the mining, but it's up to you to weigh the option when it comes to nuclear energy. All right, and hopefully this little talk here gave you some food for thought so that you can now move through your life learning more and more about nuclear energy and use what you know and learn to weigh this option.